I'm Rob Meyer. I'm here to kick off today's session on best practices in the API economy. If you are here to vote on Scottish independence, you are actually on the wrong webinar. We're talking about bigger GDP, which is the GDP of the API economy today, and one of the chief concerns around APIs is security. So joining us here today to talk about that are one of the big security experts out there in the API economy, Gunnar Peterson, a well-known software security architect, a visiting scientist at Carnegie Mellon, and today a visiting expert on our best practices series. Welcome, Gunnar.
Hey, thank you very much, Rob. It's good to be here.
It's good to have you here, Gunnar. Glad you're not voting today. Also with us is Mark O'Neill, because they always have great conversations. If you go to the next slide, I'll introduce Mark so you can put a face to the name. I think we have a picture of Mark. So Mark is the guy in the suit. He is also actually an architect who's been around for years, although it doesn't show because we use a lot of Botox here in California. Mark is the founder of Vordel, one of the co-founders of Vordel, CTO and VP of Innovation here at Axway today. Welcome, Mark.
Thanks, Rob. And hey, Gunnar. Good to be on another webinar with you.
Yeah, good to talk to you again, Mark, always.
And so with that, I think we're going to kick it off, Gunnar. Why don't we get the conversation started? We always get requests from customers we talk to about, so how do I actually make sure my APIs are secure? And the reason we went to you, Gunnar, is you kind of built up your top 10 over the years, and so we wanted to get those out to everybody. So why don't you get started?
Yeah, thanks a lot, Rob. And speaking of Scotland, there's one thing that everybody in the UK and Scotland can agree on, and that's APIs are important. And we're still figuring out a lot of stuff as we go here in terms of how to secure these things. We know they're important. We know there's breaches happening. We're going to talk about some of the best ways to deal with those today. Mark and I put our Twitter handles on here if you want to chat back with us. It's at OneRunDrop and at @TheMarkO'Neill. So as I said, we all can see that APIs are very cool, right? Even at the top, as a big company like Microsoft, when they were looking to replace Steve Ballmer, they actually replaced him with a middleware guy. Satya Nadella came up as a middleware guy. I thought a good marker of success to see how far the industry has come. Maybe 10, 20 years ago, middleware definition that I used to hear was, well, that's the stuff nobody wants to pay for. And now you have people coming up building careers on it, and it just shows how strategic getting at data, distributing data is. At the same time, there's real risks, and they're not always the ones that you think about. We're used to thinking about, how do we secure our iPhone? Do we have biometric authentication on the iPhone 5S? How do we lock down our data on our Android? Do we have MDM in place and all of these sorts of things? And no doubt those are all important things to do. But then you look, where are the breaches? Well, they're back up on the cloud side. When the iPad was first released, there was a breach the very first week against the telco site that was hosting the iPad, and Colin Powell and lots of other famous people's data got leaked when the iPad was first released, and it was just an old-school SQL injection attack. There was nothing particularly fancy about it. All of the attention went to the device, but where was the data? It was up on the server side, and that's where the attackers are going to go. You look at it, the Android app that the National Weather Service had put on, and it was so popular, so chatty, that it actually took down the server side. So the risk remains on the server side. Yes, we have new risks in terms of mobile devices, in terms of things like Internet of Things, but the old risks are still there, and to a large degree, they are even more problematic now. On top of that, we have lots and lots of different stakeholders. We've got developers that need to get code done and pushed out to the clients and to the devices. And to the server side, we've got architects who are figuring out the best ways to integrate, the best ways to get all of the different data and functionality working together. And then we have security, are running around like crazy trying to kind of, like, I feel a little bit like we're the dog chasing the rabbit, at a track, and we're trying to catch up to where the developers and the architects are leading us, and we need to do it as quickly and as efficiently as possible. And so that all has to work, of course, with users, and we'll talk a little bit about API and RESTful application today. I think the single best thing you can do at the beginning is to make sure you have an architecture-centric view of API security. That means understanding what your risks are, understanding what security capabilities you can bring to dealing with those risks. As I said, it's not just about the shiny devices in your pocket, your mobile devices. It's what happens when they talk back to the server. How are they presenting identity? How do you know that the data that's coming from them is not trying to steal data out of your database? That's a pretty tricky thing to do. It's not, you can't just slam down a suite of technologies to make it happen. You really need to think through what are your company's concerns, and then go look for the tools and protocols and skills that you need to deliver those. There's many ways to do this. The way that I tend to think about it is what I call model approach controller. And so working left to right, the model is what you're going to eventually send down to the app. That's all of the data. That's the bank transaction. That's the healthcare information. That's the user profile information, all of the stuff that you want to get down there. We're going to build authorization services, maybe logging and monitoring, risk-based authentication around that. And that's really a skill where we need a lot of business logic, a lot of business and enterprise domain knowledge. The approach is the front end. So that's the identity services, the consumers, the authentication that's exposed on the front end. A lot of people, these are all important, by the way, but a lot of people just look at what do we do as front-end authentication as the end goal of security. It's important, but that's really securing the approach, your user's approach to your application. The control should reside on the right-hand side. The controller is where we're enforcing our security policy based on our access control model. So think about things like gateways, like session management, like security token services, like web application access management. And that's a really key point that I think goes missing in a lot of security architecture design patterns that I see. The controller should be there to centralize the access control logic. We do not want to push control into the front-end approach or into the back-end model. We don't know how an attacker might come at us, but we do know if we give the ability for a front-end client to control the server, eventually an attacker is going to do that. So having a hard separation between those three concerns and having the right tools in place to deliver those is fundamental. And so I think this is first starting by developing your design pattern and then going to get the right tools in place to deliver that. Mark, what are your thoughts on using design patterns in API and REST security?
Yeah, I think it's a very good approach to use a design pattern, because then you can have the separation of concerns in terms of what's happening at the different steps. The other part of this as well is it can also link to different personas. So if you look at who's designing the approach in terms of what authentication to use in terms of the client experience, that can be different than the person who's managing the controller layer. So as you put it, the gateway security token service, the different pieces of infrastructure that are actually enforcing the security and that are doing the heavy lifting there. So it maps as well to different personas, different stakeholders that are involved, and it's a good way to approach the problem. The other thing as well is that when you look at security token services, gateways, WAM products, those are often where you can also scale out the solution too. So as your traffic goes up with APIs, sometimes we see that it's difficult to predict what the traffic can be. It could be related to an app that goes viral. It could be seasonal. you need to make sure that it scales. So this also allows you to, in your design pattern, be able to design for scale also.
Yeah, those are great points. And I should have mentioned at the beginning, we have a white paper that goes along with this. If you register, I think you can get on the list to make sure you get it emailed to you when it's available, and we'll go into quite a lot more detail on exactly how to apply these patterns. I really like the idea of using this to help you scale and to using it to take care of different personas. Those are great points. The second one we have is know and contain your assets. This one, I got to say, in working with different clients all over the world, this is something that 97% of the time is the problem. It's really a persistent, pervasive issue. And if you imagine your user management scheme, you've got users centralized probably pretty well in Active Directory and LDAP and application databases, and in there you put groups and roles and attributes and all kinds of other things that you know about the users. But access control is really a mixture of two things. It's not just the users, it's also the resources and the services and the data and the functionality and all of the things that go along with using the application. So we're good at the who are you. We're not as good as an industry at the what can you do. And we don't really have the same level of rigor around our resources. So far that hasn't been a focus. However, I think in APIs and REST security, it absolutely has to be. You have to know what you're publishing out to the world. You want to have a catalog, a way to register the services. Otherwise, there's really no starting point to assign the permissions and privileges, much less do so in a consistent way. So that same level of rigor, the same mindset that you would use to track your users in Active Directory and LDAP, you want to think about your services, your API endpoints, as having a source of truth for that. Otherwise, you just don't have a place to build your access control policy. What are your thoughts on this one, Mark?
Yeah, I think those are very good points. The other thing I'd add that APIs bring to it, a twist that they bring, is also versioning of the API. So if you look at the screenshot there, the API catalog screenshot, the catalog is a place where you go to see the single store of truth in terms of the APIs that are being used by your organization and that are internal. But these APIs can have different versions. So versioning of APIs is a hot topic, almost worth a webinar in itself. But the versions of the APIs might have different access control rules applied to them. The other point as well that I'd make is that the APIs used by an organization are not only the APIs that organization is exposing, not only their own APIs, they're also using third-party APIs. So the third-party APIs could be, for example, connecting to Salesforce, connecting up to Amazon, for example, Amazon S3 for storage. Those APIs also have to be managed for how your users are using them. So it's not the old world where you're just managing your own resources. You're also managing access to third-party resources. And frequently, users really don't care if this particular part of the app has been serviced from the cloud by a third party. This other piece has been serviced by, let's say, ultimately going into a local SAP system. It's all accessed together with APIs, and you have to have a single view on those. And this really is the next generation registry repository for people who remember that. With SOA, you had a registry repository. It was really for your internal resources. With APIs and for API security, you have your API catalog for your own APIs, but also the ones that your business depends upon.
Yeah, the third party is a great point, too. If you consider those 2 points together, the third party plus the versioning, well, now all of a sudden you're using an external API. You're also not in control of when Salesforce chooses to upgrade or version their APIs. So you can get to a position where you might have to upgrade a version and do it really quickly because an external third party has upgraded theirs. And so you definitely do not want that to turn into a fire drill or a Keystone Cops episode. You want to have a centralized place where you can do that. Make that change in one place. Number 3, I feel pretty strongly about this one as a missing link in the industry as it relates to architecture thinking. I was one of the authors on the Open Group Enterprise Security Architecture Guide, and what I noticed when I worked on the latest version of that guide for the Open Group was we did an excellent job in the guide about talking. The previous authors did a great job talking about access control and virtual directories and policy enforcement points and policy decision points and standards and single sign-on and lots of other things. But it hit me that that handles a class of problems that we have in the industry, but it misses an entirely different class. So we spend so much time as security architects and security engineers designing for security and building security in, building better authentication and authorization, building better registries and repositories. It's all important. It all has to get done. However, there's another class of problems which I call malicious users, and we need to also design for malice, people deliberately trying to misuse the systems. And when you think about the problem of designing for malice, it gets you to a different set of controls than designing for security. Designing for security, building security in, it's about building a better access control protocol. Getting OAuth tokens in people's hands, getting single sign-on placed. Designing for malice, you get to things like input validation, output encoding, testing that you don't have any known vulnerabilities, making sure that the user is not sending you SQL code and trying to drop a SQL injection attack on your database. Those are things that you cannot really solve with an access control protocol by itself. You need to be able to design for malice as well as for security. Again, that's where centralizing that logic in something like a gateway is way more convenient for the architect than trying to build it into all of the endpoints, build it into all of the applications. Try to centralize that design for malice logic in the same place that you design for security. What are your thoughts on malicious users, Mark?
I have certainly a lot of thoughts about malicious users, but I think the key thing here, and you used the analogy earlier, Gunnar, is if you think about the Keystone cops, where they're running after the criminals one by one and whacking them with the truncheon. In that case, it doesn't scale very well. More criminals come along and you whack them. But in this case, if you take the whitelist model, rather than saying, there's this exhaustive list of many, many different attacks that we want to detect and block, that with REST APIs that for the most part use JSON, there are still quite a lot that also use XML. If you define what the correct format should look like, and then you first enforce that, then you're narrowing down your problem space, you're narrowing down the attack surface, and then you're not exhaustively going through many, many different possible attacks. So actually in the example there, you see, for example, age. Age must be an integer. So rather than saying age must not be these 1,001 different SQL injection and other content level attacks, first of all, you're making sure it's an integer, and that's going to rule out a lot of content that isn't, and then you're at that point enforcing the actual content level attack prevention. So that's one important part. The other part as well is to actually test your APIs. So you see in the screenshot behind there the API tester tool. So this is a tool we provide where you can create basically attacks on your own APIs. You can see there a SQL injection attack that's been teed up to send to a particular API. So it's good practice to do vulnerability assessments on your own APIs and to make sure that the API providers that you're relying on are doing this too with their APIs. You can put on the black hat and be the malicious user in order to make sure that the APIs that you're exposing or that you're depending on are not going to be vulnerable.
Yeah, and I think that Keystone Cops is if you put yourself in the shoes of somebody responding to an event, and I don't know on this call of all the people on the call, how many of you have actually responded to an event. But if you've ever done it, it stays with you, right? Those are road rash, road burns that stay with you. You never really forget what it's like to respond to a big data breach or a major security incident. And if you put yourself mentally in that space, the very last thing you'd want to do is have tremendous uncertainty about how you could deploy the fix. It takes a lot of time sometimes to figure out what the problem is. And then there's usually quite a long triage phase. Maybe it's only a couple hours, but it probably feels like days to you if you're the one responding. Once you get that triage and you're ready to roll it out, the last thing you want to do is to have to go to 138 places to do it. If you can centralize that, it gets you out of the whack-a-mole game, and you can actually deploy your fix quickly and effectively. And that really ties to number 4. API attacks are happening. Monitor for flaws yourself. You don't want to find out after the fact, that there's an issue. The riskiest thing is not that you have a vulnerability in your system. The riskiest thing is to assume everything's perfect, act accordingly when in fact everything is not secure. So you want to go on be forward-leaning and to be progressively monitoring for flaws in your applications. Before I turn it back over to Mark for his thoughts on this one, I should mention we have a questions panel up in the webinar too, so please feel free to fire questions at us as we're going here. We'll get to as many as we can. Mark, what are your thoughts on proactively monitoring for flaws?
Yeah, it's very important, and the example here you can see Snapchat I think is a very good example, because if you follow the story about what happened with Snapchat, they have an API, and that API allows you to send as input a phone number, and it'll send you back info on whether or not that phone number is registered as a Snapchat account. Now, they intended that API to be used by mobile apps where you'd key in your contacts' phone numbers, or you take it from your contacts list on the phone, and it would helpfully tell you which ones were signed up for Snapchat. Now, what they didn't realize was that that API actually could be called in an automated fashion. So people were able to write scripts which would exhaustively go through every possible phone number in the US and Canada, and then would call the API, and it would come back with a yay or nay on whether or not they had a Snapchat account. So in that way, you were able to get the phone numbers of every person who uses Snapchat. So that obviously was a API vulnerability. It was the API being used in an unexpected way. Now, the interesting thing about that was that this was done a number of times over a number of weeks, and in fact was also blocked. Snapchat didn't notice this happening at the time. So what this said was there wasn't API monitoring happening. There wasn't any kind of alert that it's unusual for one person, for one user, to be checking the phone number of every single possible phone number in the US. And that if there had been a gateway in place, for example, as you mentioned, the gateway as the way to enforce the security, that huge spike would have been very obvious, very apparent. And in fact, the people who found this vulnerability had to alert Snapchat about it, even after they blogged it. So that's one example. You could argue it's just a consumer service, wasn't handling, credit cards and so forth. But that's the kind of thing that you don't want your enterprise API to be vulnerable to.
Great. So we're actually going to start a couple questions, and let me launch the first one. It is not whether you think Scotland should be an independent country. We're actually starting off with hearing about what kinds of projects, what kinds of API management projects are you working on today. Please select all that apply. And remember your answers for what you're doing today, because the next question is going to be what are you doing in the next 12 months, just to get a sense of where the audience is today. So open APIs are really APIs you're exposing out to any developer to consume. The cloud integration type of project is consuming any kind of REST API or web service for cloud-to-ground or cloud-to-cloud integration. Mobile projects or the Internet of Things, it could be bring your own device internally or an external mobile application. The partner B2B integration could be any kind of web service like a payment service or a REST API for Uber. Let's say like a pay with points example between American Express and Uber. And then the internal integration, if you're using REST APIs or web services in a lightweight integration use case, and you decided to use API management as the approach. So we're going to let it go on a couple more seconds. We have a little over half the audience that's answered. We're getting a few more answers, but I think we'll close it out, and I'll go push the results. So wrap up, and we'll go push it out. Great.
All right. Thanks, Rob. So,
two-thirds of the people voted.
Very good. So, on number 5, think mobile and beyond. The front ends are absolutely exploding. I was thinking when I was working on this paper and presentation, thinking back 10 years and the problems that we worried about 10 years ago in security. People were really, really adamant that monoculture would be a problem. A single Windows virus could just take down absolutely everything. And we're not really there anymore, right? We have many problems in security. Monoculture is less of a problem these days. There's so many different kinds of devices. I pulled this heat map for the number of Android combinations. If you look at the different Android manufacturers, Samsung, HTC, Motorola, and then how they apply across the different mobile network operators. Even a couple of years ago, this was a major problem. This is 11,000 unique combinations of Android devices. And that's just Android.
And Gunnar, I apologize. I've actually opened up the second poll to see what people are doing tomorrow. So
very good.
While you're going through that, we'll let people answer the question.
Okay. We're testing on multitasking here too. But so we just saw the iWatch released. We've got iOS, we've got Android, we've got clients, we've got B2B integration. The major problem, at least in my view, is how do we consolidate and centralize security enforcement across so many different endpoints that all have one thing in common, which is they want to access some piece of our back end, some piece of our user identity, some piece of our enterprise information. And you're not going to be able to get consistent security policy across that many different devices, and the problem's only getting worse. And so we need to think beyond what we can do on the device and think outside of the box to try to centralize that in another place. Again, a gateway is an ideal location to centralize the security enforcement. Mark, do you have any thoughts on this one?
Yeah, I think with the proliferation of devices, as you say, including now the Apple Watch, but the Samsung Gear and others, we've seen this for a while. When you talk about APIs and web APIs, often it goes hand in hand with mobile. That's often the reason why JSON-style APIs are being used versus XML, for example. Now, in that case, the API itself is a good place to enforce security because then you're not having to deal so much with the proliferation of different types of clients, but you can put different treatments of different clients at the API level. And in fact, just a comment on the poll. We're all seeing the results now of the second poll. I thought one of the interesting things was, we've just been talking about mobile and the Internet of Things, and that's certainly somewhere where people are going to, but it's very noteworthy that the leader for both polls, so what people are doing today with APIs and what people are doing tomorrow, the next 12 months, with 12 to 24 months with APIs, is internal integration. That's very interesting because what we've seen is that mobile initially drove lightweight REST APIs in terms of that technology. Now what it's done is it's come into the organization and is often displacing the more heavyweight SOAP and XML style web services, and indeed more heavyweight types of integration of the past. For example, using a heavyweight ESB that would have been used a number of years ago, but instead saying, well, we're going to use APIs for this. We're going to put in an internal API gateway and be much more agile. So the internal aspect is very interesting. Of course, that doesn't mean that you don't have to think about security. We're all on this webinar thinking about security, so you still need security for these internal APIs, not least if the data you're dealing with, for example, can include private customer data, healthcare information, PII. You still have to think about security for your internal data.
Yeah, in fact, a lot of people, from what I've seen, they have a tiered architecture, and sometimes they're using a gateway kind of approach to integration for adding the layer of security across departments or adding the SLAs across departments. So security comes in at that layer as well.
That's a great point. And I think the number 6 that we have here, thinking of sessions, not just APIs, that ties directly to, we're going to look at an example here in a minute of an external application, but anytime you're talking about integration, it's what does the end-to-end session need to look like? So we've got OAuth access tokens that we're going to pass down to the client. How do we have to configure the authorization server and the resource server to make sure that they're scoped appropriately and that we're checking the permissions at the right level of granularity to make an authorization decision? And how do we store that securely on the client? One of my favorite examples of a mobile app, this is externally facing, but it's really, you can imagine, integration challenge. Tim Hortons, also known as Canadian Dunkin' Donuts to some people, they introduced a mobile payment applications at 4,300 restaurant locations in the U.S. and Canada. And think of how many different sessions are running here. Somebody had to provision the payment card down to the mobile device. There's the user session that's running locally, and then there's the payment session. So at a minimum, there's 3 or 4 different sessions that all need to get threaded together. Those are substantial challenges for anybody rolling out a security architecture. Mark, what are your thoughts on OAuth in the API security model?
So OAuth comes up a lot. I think OAuth is certainly a very hot technology right now. In the past, for example, SAML occupied that space. The thing about OAuth is that it very much, again, links to mobile and how people use APIs. So, we've all had the experience of saying that we work in a particular field and have difficulty explaining it to someone outside that field about what exactly we do. OAuth is one of those examples where the regular person using an app on their phone doesn't know what OAuth is, but they do know that they can authorize the app to do certain things on their behalf. So, for example, they can authorize a fitness app to tweet and say, hey, I just ran 5 miles this morning, which I'm sure their Twitter followers are riveted by. But basically, what you're doing there is using OAuth. So you're you're delegating authorization to an app to do things on your behalf. And there's obviously a lot of technology that goes with that. Some of the security issues around APIs have focused around OAuth. So the buffer example that was mentioned, that is an example where a OAuth token was issued to an app, and then by being able to compromise the app itself, you were able to then compromise services that it uses based on having that token. So you need to really think about OAuth tokens, how they've been secured, how you're securing OAuth itself. One of the ironies of OAuth 2.0 is that it itself requires security. So some of the security provisions that were in OAuth 1.0, arguably it made sense to have those external to the spec itself. Were taken out, so that means that you have to secure it. You also have to make sure it scales. So OAuth, because it's so often linked to mobile, if your app goes viral, if your API gets a lot more usage than they expected, then you need to think about the storage of all of those OAuth access tokens. What if someone travels to a different country, they access, for example, APIs that have been surfaced from a different data center, from a different Amazon location, for example? You need to make sure that the OAuth access tokens are being persisted across there. And you can see in the screenshot there, one of the ways we do this at Axway is we embed Apache Cassandra. So that enables a very highly scalable in-memory database that can allow your OAuth access tokens to follow you around when you may be accessing APIs through different gateways. So that's important. Also, web access management that you mentioned earlier, Gunnar, that has a place here as well. People using web browser clients, they're authenticating. You need to think about the sessions there as well. So you see that also on the screenshot. So sessions come into play for security reasons, also usability reasons, and the very fact that people are mobile and may be accessing the API, through different countries and shouldn't have to be, re-logging in every single time.
Great. So let's talk about making life easier, simplifying the user experience. Like Mark just hit a number of these points in a couple different ways, right? Users, we're not going to turn users into security experts. If we've learned that by now as a security industry, no matter how many awareness training exercises we do, people still think they're going to get $5 million from a long-lost relative in Nigeria. So we certainly cannot expect them to understand the end-to-end OAuth protocol or any other security protocol that we might choose to do. Instead, we need to focus on the system to be as secure by default as possible and to make things as simple as possible. And I would say that goes both for users as well as another kind of user that we think less about, frankly, in security, which is developers. Developers are users too. We want to make it easy for developers to do the right thing. We want to make it easy for users to do the right thing. So ensure that the default mode is as secure as possible, and don't expect either the users or the developers to go through 18 different steps to try to make something secure. It's our job to design something with secure defaults. You don't want to be, if you're in a car, you don't want to be getting into a car crash and have a pop-up screen that says, would you like me to deploy your airbag now? Right? You don't have time. Right? You want the safety mechanisms to understand what the asset is that's protecting, to understand what the event is it's responding to, and to act accordingly. We can't expect either the users or the developers to do that. I think people get that on users, but developers are users too, and you really have to make it as easy as possible to have testing tools for them to use, to have deployment tools for them to use, and to have client tools so they can make the appropriate calls from the client to the server. Mark's hit a lot of examples on this already where that wasn't done, and those absolutely create issues. Mark, what are your thoughts on simplicity?
Yeah, and I think this is one of the big lessons from the older world of SOA. We're often asked, how is API management and the API economy different from SOA? One of the key differences is in SOA you had the registry repository, which was a diabolical user experience for the developer when they had to think about things like UDDI to register their web services there. They had to very much be coerced into looking up the registry to find reusable services. With APIs, that lesson has been learned. So you have the concept of the API developer portal, and that's a much more pleasant experience for the developer. They can go browse APIs, have a self-service, sign up, be able to do in-place testing of APIs, tee up test messages, send them through very quickly, as people say, go from zero to hello world. So you can very quickly create your app and be using the API. In the API economy, if you don't do this, then the developer is going to say, next, look for a similar API from some other company that's offering a similar service and may well use that. So the developer portals are very important. It can't be a case of if we build the API, they will come. It's important to have the self-service aspect and simplify the developer experience. That goes to things like forums as well. You can see in the screenshot there, having forums, blogs, the ability to get quick answers about how your APIs are being used. Also, testing is part of this as well. One of the questions that came up was about the API tester tool. That's provided as part of our API management solution. But the API tester tool as well is something that you can give to the developers and also to the people who are going to be using your API and say, hey, here's a way to tee up test messages. And for anyone who's ever done development, if you see a successful message go through, that's very useful in terms of designing your app and seeing what you might be doing wrong in your app. So that's important as well in terms of the developer experience.
Yeah, one last point on both simplifying for users and simplifying for developers. I think users don't expect that they're security experts. They don't expect they know the answer. They're just going to click through, and we just need to make it easy for them to do the right thing. Developers, on the other hand, a lot of times they think they do know, and so you need to anticipate that they're going to ask a second and a third follow-up question, and you need to make sure that that it's integrated, to the client, to the testing environments, that all of those dots are connected for them. This number 9, this is a people thing. There's an old consulting rule that it's never a technology problem, it's never a process problem, it's always a people problem on some level. This really I see as an opportunity for security teams to add value. We're always in security trying to get ourselves into a position of, hey, how can we get involved earlier in the process, farther to the left of the design and development lifecycle? We don't want to get involved 2 weeks before we go live and try and shove crypto in the corner of some application that's fundamentally broken. We'd rather be involved earlier in the design and architecture phase. And in the API economy, I think there's actually an opportunity here for security teams in different enterprises if they choose to take it. There's a need that's been recognized in a lot of companies to have a curator, somebody who is responsible for deploying APIs for the enterprise, making sure that the policies are in place, not just security policies, but overall governance policies. That role, that curator role, can easily be filled by somebody on the security team or in conjunction with the security team. It puts, in my view, security teams exactly where they should be to be in the right place to foster integration with development teams and to make sure that things don't go out the door without having the security seal of approval on them. What are your thoughts on this, Mark?
Yeah, and that's a very good point. I think the other thing as well, and we're alluding to it here with the cartoon, is you can't always expect developers to tell you as a security professional about what their APIs are going to do in advance. Often it's at the last minute. We see this a lot where API is about to go live and people think, oh, what do we do about security? So thinking about authentication, which pattern to use, thinking about threat management, and things like quotas as well. So being able to have that engagement with developers about APIs that they're working on and be able to have security as part of that conversation is important. The other thing as well, and this goes back to one of the earlier points I made about Snapchat, is that once you have a gateway in place and once you can be able to see API traffic, that's also a very good way to see, for example, changes that are being made to your APIs, new versions, new APIs, even at a testing level. So that you can then have, for example, default security policies that are applied and be able to proactively have that type of visibility. Again, that's part of the deployment pattern. If you have, apis.mycompany.com, developer.mycompany.com, going through a gateway layer, then you have that single visibility there that's useful. The other point as well, and this echoes something I mentioned earlier, was some of those APIs that you're thinking about the security of could be external APIs that you're using. So you might want to enforce security rules on them, but also it goes beyond security. You might, for example, rely on an API as part of a business process. So you want to apply an SLA to it as well. So you want to have availability rules as well that are being applied. So you know if that API is not behaving as it should. So it really is all about having that visibility, having the monitoring, for your APIs. I think with that, we're ready for the next poll.
Yeah, we wanted to shift direction a little bit and talk about some slightly different integration patterns. So I'm going to launch the question. This really started with some bidirectional B2B integration, but it's really changed with the addition of mobile devices. So the question here is, what kinds of integration, more bidirectional integration, is your company planning to support in the next 12 months? Are you doing bidirectional B2B integration where both sides are initiating some kind of communication? So both sides have to trust each other. Are you doing push notifications to mobile devices, which makes the mobile device more of a server than a client? Are you doing device-to-device communication? Device-to-device communication, as one person pointed out in the question earlier. Are you doing any kind of batch, not just real-time bidirectional communication? Or are you getting into Internet of Things use cases in planning? Because I noticed just about slightly over 60% said they were getting into Internet of Things applications. So what kinds of bidirectional communication are you doing with the Internet of Things? Check all that apply. I'll leave the poll open a little bit longer. We're getting close to half the people having answered. So I'll give it another 10 seconds, and then we'll close it out. All right. I'm going to close it out now.
So it looks like B2B, bidirectional file transfers, push notifications for mobile, and Internet of Things in that order. Is that how you're reading those results, Rob?
Yeah, that's one thing I can do on this webinar. I can read the charts, and that looks right to me.
So I think the reason we talked about this, this is number 10 on our list for REST and API security, because it's fundamentally a different way of thinking about security. We're used to thinking the server is the castle, and we've got a moat and a drawbridge, and you have to get into the castle to do what you want and access your data. We're going to authenticate you before we drop the drawbridge down and all of that sort of thing. And that's a fine model. There's no doubt that that's a good model. Here's what's different about bidirectional communication. If we're doing bidirectional file transfers, if we're doing push notifications to mobile devices, if we're doing authentication over SMS or two-step verification, the client is now being pushed data by the server. So we've reversed the flow of the communication protocol, and we've reversed the flow of the security protocol. And I think a lot of systems are not necessarily factoring in how that really fundamentally changes really everything, right? WebSockets changes everything. Push notifications, pushing updates down to clients. Are the clients really as secure as the server was before? I think that's an open question. What are your thoughts on this, Mark?
Yeah, WebSockets is something we're seeing a lot now that it's part of HTML5. I've seen this personally with actually customers that are doing real-time data about, for example, the odds on different sports events, or even, let's say, the odds on Scotland declaring independence or not. You want that information to be bang up to date. Also, obviously, we're seeing this in financial services. There's very interesting companies like Lightstreamer that are providing WebSocket servers for providing real-time stock information. So that changes the game in terms of the ability to apply security, because you don't have the client and server. As you can see in the diagram there, once the WebSockets session is set up, you have bidirectional messages. So you can think of the client being the server, and the server initiates the connection over the WebSocket to the client. So it subverts the old one-way communication. It's, as people used to say back in the day, it's firewall friendly in the sense that it's completely invisible to the firewall that has the web ports open. That has to have security applied to it as well. And you can see over on the right as well that there's also push notifications, the ability to leverage devices themselves as part of two-factor authentication. So these are all different ways of thinking about security. Mobile notifications are particularly interesting because they can also subvert the mechanism of client-server 2. So typically we see that when people are using API management for managing usage of APIs, they also want to bring the mobile notifications under that security umbrella as well.
So what I wanted to do before we go on is ask one last question, because this one actually comes up quite a bit, and it's really about the data. So when you're doing APIs, when you have APIs going back and forth or web services, what kinds of data are crossing the firewall or getting passed between departments? Is any of it regulated data or personal information about customers or partners that you want to protect? Or is it any data that might be coming up as part of an audit that needs to be tracked as part of an audit? Just check all that apply. I think what we might do also is have a don't know, because often people really don't know what kinds of data is going across in some of these APIs.
Well, you can try telling that to an auditor, Rob, that you don't know, but I don't know how many will believe you.
That's just going to start an audit. So we'll give it a couple more seconds.
I guess the other interesting thing related to the earlier point is these APIs can be internal as well. We saw that internal APIs was actually the front runner. These also can have this type of data.
Yeah.
So I think it's also interesting that it's not just data that goes across the firewall.
Yeah. I'll close this out and share the results. So interesting, personal information stands out.
Yeah, I mean, I think that makes a lot of sense. There's quite a lot of momentum around these data breaches, around privileged use of customer data. These things are not going to go away. They're long-standing problems. So we talked about some of the things that are, I think, in my view, new to the industry. So designing for malice, the 10th one in our top 10, being bidirectional, making sure that the client can authenticate to the server, but also the server can authenticate to the client. So those are 10 of the biggest issues we see. But security is a big field, and we felt like we need to give it our extra 10%. So we're actually making an exception here and making our top 10 list a top 11. And let's just bring it back to what our real focus is. There's so many things have changed over the years. The architecture's changed. The security has changed. The things that we're securing really haven't changed, right? So at the end of the day, what we're really concerned about is securing our users' data, regulated data, personal data, auditable data. What they all have in common is we need to make sure that we're putting our security around our assets that are most valuable, and that means showing that we care as security architects, sending the very best security with every message, with every bit of data that we send across the wire to our clients, whether they're an FTP server running an enterprise backend or whether they're a shiny new iPhone in somebody's pocket. We want to make sure we're encrypting the sensitive data, signing it, and hashing those messages to protect it wherever it's going to and from. And that's one thing, frankly, that hasn't changed. So many things have changed in this business, but look for the things that haven't changed. This is still the dominant issue in security. I think if we were on this webinar in 5 years or 10 years, data security is still going to be the dominant issue. That's what attackers want to get That's what users want to protect, and that's what, frankly, enterprises run on. So that's the lifeblood that is valuable to all of those stakeholders we talked about at the beginning, and that's really where our focus needs to go. We don't want to ever lose sight of that. Mark, what are your thoughts on data security?
Yeah, I think that the thing about data security is that even though we've talked so much about securing APIs, it's really all about securing the data that's going through those APIs. So you can see the APIs as being like a conduit for data. So if you say, well, what does it mean to make an API secure? Well, it means the data that's going through the API, let's say it's the hospital open or visiting times, let's say it's appointment times to see your doctor, let's say it's prescription information. That information has different sensitivities, different security that's going to be applied to it. So think about the data, focus on the data as we say here. The data itself is signed encrypted. If it's going to be sitting on the network, sitting in logs, think about that it's encrypted and signed. As well also, particularly if any of that data is going to be stored on a mobile device, you want the data instead to be on top from an API instead. So it's really all about the data, and actually we talk about governing the flow of data. That's the same data that could be going through an API and then hitting B2B, managed file transfer, hitting a JMS queue, going into different systems. In that case, you not only think about the API, but you think of the full life cycle, and that means securing the data itself.
Yeah, I mean, and security in general has such an infrastructure focus, and I think that's for historical reasons. You can see why we have this focus on network infrastructure, on host infrastructure, server infrastructure. But I think it's to the point where we miss what's most important. If you go to a place like Google, and you ever walk through a data center at a place like Google, they have servers from the floor to the ceiling. And if you're the server manager, you come in on a Monday morning, and you find out that 5 of them have been fried because they overheated or whatever. They don't even try to fix those servers. They take them out of the rack, they throw them in the garbage, and they put a new one in the rack. So we don't really value the infrastructure. We value the data, and our security is still about risk, and risk is still about value, and we need to make sure we're putting our security policies, tools, capabilities, process, and people as much as possible way, way more in the direction of securing what's valuable. So with that, I think we'll close it out for now. I'd like to thank everybody for your time, and thank Mark O'Neill and Rob Meyer for your input and for a great conversation today on API security. Definitely follow up with us at Axway or on blogs and Twitter, and definitely enjoyed it today. Rob, I'll hand it back to you.
Yeah, thank you, Gunnar, for kicking this off and going through your top 11. Next up, I think in October, we'll be doing a webinar on DevOps, so you can expect an invitation on that soon, but it's basically sort of the continuous improvement approach to developing, well, really developing anything, but how it's applying to API management. We'll get that out for you. But from all of us here, from Axway, whether we see you online, or I guess we'll see you maybe at the security conference, because I know Mark is speaking in Atlanta at the end of September at the ISC, at the International Security Conference. We'll see you soon. So thank you all.
Thank you. Thanks, Gunnar. Thanks, Rob.